Saxon's Calculus, Lesson 27 is the derivative. Now, the derivative is the first time that we're talking about a specific calculus term. And they're going to take a little bit of time here. Therefore, we're going to take a little bit of time as well to talk about what this actually means. So the derivative of a function equals the rate of change of the function, and the value of the derivative for any value of x is the value of the slope of the tangent line to the graph of the function at that value of x. Ooh, okay, I know that was wordy, but basically it's saying if whatever curve you have or graph for the function that you have, the derivative is where you are creating the tangent point where it's touching, and I just drew that one at a slant. It should be where the slope is 0, it clarified. So it's talking about what is like the slope, the rise over run, the rate of change that it takes to go from one spot up to the tangent spot where it's going to be having a slope of 0. Now, they do talk about the fact that the limits, which we've talked a little bit about, the closer you get to here, the tighter that change becomes, the closer to 0 it becomes. So the limit is the same as the slope there when the limit would be 0 when you're reaching to that point. And then they move to, they're trying to show it to you in a diagram, and I guess this part is kind of helpful. If I have this curve and I'm graphing it, and I've got a dot here and a dot here, and I'm sending a line through those, there's a distance here and a distance here down to the x-axis. And so the slope of this line is tight enough to the curve that you get that they're ignoring that little gap in essence. And so they're saying, let's call this one f of x, and let's call this one f of x plus the change in x. Now remember that we learned that little triangle with the extra darkened on that side is change in x. Then when you get the rise over run, and of course you're subtracting things when you do that to create the slope, you're doing f of x plus change in x minus the f of x. And that would be the rise part. The run part, the bottom part of the fraction, would just be the change in x. And so they're saying, okay, let's use the slope of that line to create the change in y over the change in x. And therefore, the formula for derivative says this: the limit of the change in, I believe it's x, yes, change in x to 0 gives you this formula. It equals f of the change in x, oh, backwards, knew that didn't feel right, x plus the change in x, it's exactly what I was just writing over here, minus f of x all over the change in x. So you are supposed to memorize this as being the derivative formula, fraction, however you wish to call it. Now, that looks complicated. And for the rest of this lesson and the few in the future where they have us use this formula, yes, it is a little bit messy. But mathematicians got tired of having to deal with the messy over and over and over again. So there's a shortcut coming, which is really super helpful. And then it means I can stop using this formula. However, you always want to recognize this is super important, and it will show up on standardized tests, and they expect you to understand that it means derivative. It is a part of finding a slope, but it's the limit of that slope. All right, so, now before I move on to the actual examples and use this, there are a ton of ways for the book to ask you to find derivative. where they want you to use this formula. So I will list the ones that the book has. D over dx is used a lot, and it just means find the derivative. Also, a capital D with a little x. Or they can say d over dx with f of x. Or the same thing with the d of x with f of x following it. So find the derivative of that formula. It's just the extra way of giving you the formula. Also, and again, that d over dx thing is in there, and it could call for it for x squared. Now, these are just like, this is an okay format for find the derivative because it's saying, hey, use whatever the equation is here for this. In this example, they're saying this is a specific equation. So just the d over dx is the part that you should recognize is asking you to find derivative. They will also do a lot of the time d over dx with y. And then the other format is dx over dy. That also means find the derivative. And then their final one is dxy. But you kind of get the feel there for the different ways that they're asking you to find the derivative. So in example 1, it says y equals x squared. Find dy over dx. So it is asking me to find the derivative because that's what they gave me. So in our lovely little fraction, we have the limit of the change in x going to 0, and then we have our fraction. So everywhere I had this x plus change in x or x part, I'm plugging in the given equation. So for this part where it's x, I'm plugging in x squared plus I knew it felt like I wrote something incorrectly, and I did. Okay, so this is the first time you're seeing this, and I don't want it to confuse you. I'm going to get rid of this square. It's actually going to come back in just a second. So what this is the x plus change in x is being plugged into the formula you were given. So this should be x plus change in x squared minus, according to the formula, and then where we have the f of x, we are plugging in the x squared, and then there's nothing I can do about that change in x in the denominator. Now I want to FOIL this out and simplify it and see what I get. So x times x is x squared. That's where it comes back. Then x times change in x, doubled for the middle term, is 2x change in x, plus, and then change in x squared is change in x squared, minus x squared, there's nothing I can do with that one, over top of course, change in x. Now, x squared minus x squared cancels off. I can pull a change of x away from both of those. So in this one, I'm left with the 2 and the plus. And if I pull one change in x out, I'm left with another change in x over top of that change in x. And then those will cancel off, and I'm left with 2 plus the change in x. Did I lose an x somewhere along the line? Oh, I did. Fiddle, it's right there. I just forgot to write it over here when I factored out. Yes, yes, yes. Okay, so I have 2x plus change in x. Now, this change in x part, since I'm dealing with limit, the closer and closer to 0 that I get, I said you get 0 out of that slope. So this part drops off to a 0, and it just leaves me 2 of x. So the derivative of the x squared formula is 2x. Oh, to get to the shortcut. All right, example 2. If y equals 4x, find dx of y. So again, derivative format that it's asking for. So we know that we're plugging in with the limit, change in x yielding to 0. That's the other way you know to plug in a 0 when you get to that point. And then we have the formula. So we have whatever is given to us being 4 times that minus whatever we were being given all over the change in x. So what were we given for the formula? We were given 4 multiplying with the x plus change in x minus the 4x. Okay, yeah. Now we distribute. So we have 4x plus 4, make sure you can still see that, 4 change in x, 4x, 4 change in x, minus 4x all over change in x. 4x minus 4x cancels off. That just leaves this, and that cancels off. So I don't actually need to be plugging a 0 in anywhere. I just am left with a 4, and that's the derivative. Example 3. Use the definition of derivative to show that the derivative of a constant function is 0. So they're not giving me anything. There is no variable. So if you plug in nothing into this x plus change in x, if you're plugging in nothing there minus nothing plugged in again, then that's nothing in the numerator. And then the change in x is in the denominator. Well, 0 divided by anything is going to be 0. So I just proved with the fraction that the constant function, so if, oh, I guess I will write that as change in x, is 0. Okay. So it's saying if the only thing I'm given is a constant, a 0, a 4, a 3, a 2, it doesn't have a derivative. Its derivative is 0. All right, so then in example 4, it says f of x equals 1 over x, find dy over dx. So again, I know I'm looking for a derivative. So we've got our limit with x, change in x, wait, what was it? Change in x yielding 0, that's what I thought. And then we have our plugging into 1 over. Now I have a debate here. Do I want to do it in the 1 over format or make it negative exponent? I don't want to deal with negative exponents. Okay, so we are going to fill into 1 over. So for this first one, that was 1 over x plus change in x minus, and then the exact 1 over x all over the change in x. In order to put these together, I have to have a common denominator. So that's going to be x multiplying with this unit. So this one needs the extra x piece. This one needs the unit. So when we just 1x or just x minus, now I got to be careful that I distribute this minus with all the parts. So minus 1x or minus x, and then minus this one makes minus change in x all over the common denominator of x plus change in x. And it's all over change in x again. So if this one is written as a fraction, it's implying over 1. Then when I flip that to the top, it's going to 1 over change in x. 1x minus x is going to cancel. Negative change in x over this change in x is going to cancel. So I basically have negative 1 in the top over my, do I want to distribute it? Yes, x squared plus x change in x. Now at this point, I do have to plug in my change of x is 0. So x times 0 is going to drop off here. And so all I'm left with is negative 1 over x squared. And that is the derivative to that original equation. Oh, and that is the last example.